everyone, it's Judy Warner. Thanks so much for joining us again at this week's Ecosystem Podcast. Today I'm joined by Tim Wang-Lee, who's an SI and PI Applications Scientist at Keysight. He's going to talk about trends in the industry and how the whole industry is working to have software solve disconnects between hardware engineers and SI applications. I think you're really going to enjoy this view from Tim, who gets to talk to engineering teams all over the country. Now let's jump right into our conversation with Tim Wang-Lee of Keysight. Hi, Tim. Thanks so much for joining me today. Why don't you take a moment and introduce yourself to our audience, especially tell us a little bit about your recent academic exploit and your claim to fame with one certain Dr. Eric Bogatin.
All right. Hello, Judy. Hello, everybody. My name is Tim. Now, Dr. Tim, as Judy would call me. I am the very first student of Eric, and my dissertation focused on the dance between simulation and measurement. And it took me 6 years, but hey, I finally got my PhD to show for it.
Well, congratulations. That's no small thing. And I've talked to Eric about you, and he's a very proud professor and speaks very highly of you. So I'm really excited to get to know you and share you with our audience. So in that your dissertation was on this dance between hardware and SI engineers, I thought you're the perfect person to talk about an existing bottleneck that exists between hardware and SI engineers. So why don't you unpack what's problematic in that space of the workflow between hardware and SI engineering?
In our research and our interactions with customers, I'm finding out more about this dynamic where we have on the very left-hand side, your layout engineers, in the middle, hardware engineers, and to the right, your SI specialists. Usually the hardware engineers would finish their layout and toss it over to the SI engineers to do signal integrity analysis. But since there are fewer SI engineers than the hardware engineers, SI engineers have to do the heavy lifting, hence creating what I called a verification bottleneck in the process, meaning that it takes longer for the SI engineers to pass back the results to the hardware, slowing down the entire design cycle.
So when you say heavy lifting and it takes them more time, why is that?
That is a very good question, because usually if the SI engineers are going to do an SI analysis, they want to simulate all the nets, everything, because they want to catch even the tiniest problems between planes. It's no longer just a singular narrow focus. It's holistic. It's a holistic approach to the design, whereas hardware engineers would focus more on section by section. And that's why it takes a little longer for the SI engineers to do the analysis.
Okay, so because of this bottleneck, usually when we talk about bottlenecks, it's not a positive thing. So because of this delay or this back and forth, then the SI engineer will then pass some things back for the hardware engineer to modify, correct?
Right.
Okay, and then what is sort of the unintended consequences of that bottleneck? What's the impact?
Well, the impact is you would purposely slow down the design cycle, and you create this, well, I've done my part, it's now their problem situation. I think the throw it over the wall, right? Once you have done your job description, you say, hey, I'm going to clock out and enjoy this nice beer. And what we're trying to do, I think, as the industry is going to address this problem is if we can just everybody as individuals do a little bit more and make this transition between A and B, this layout to hardware to S engineers, make the transition a little more smooth and connected, then I would say the workflow will be better and the design process will be better.
So I'm assuming what you're proposing then is more ownership with each stakeholder is what I hear you saying. I think about when I was a kid, we had this electronic game called Hot Potato, and you'd set the timer and throw this plastic potato and throw it around in a circle to your friends. It feels like a little bit of Hot Potato, like, there, it's yours, I did my part. And then because of those disconnects, and I always say in engineering, everybody's innocent, because I feel like we're all holding dissimilar pieces of the puzzle and trying to put this complex, high speed, high frequency electronic system together. So I'm assuming that if we get more ownership between each stakeholder, then it will speed things up. Because you mentioned intentionally slow things down. Would this help speed things up then?
Oh, exactly. Like you mentioned, the ownership and taking more pride in your work. It's no longer just you're finishing your job description. You have the purpose of your job is to finalize this design so that the hardware engineers can do their part to finalize the section by section check. So then you optimize the workflow to SI engineers. And if we take ownership, take pride, and then if we have, as an industry, have tools that empowers individuals to perform these actions required, then, hey, I hate to say this, but the world is going to be a better place.
Well, I like what you're saying, but I'm wondering if to do that, then we need to give both ends, both the hardware engineer and the SI engineer, kind of this dual transparency. So in the interest of making everyone successful, getting time to market, removing inefficiencies, and I was talking to, I don't know if it was you, Tim, or someone at DesignCon was saying for every one hardware engineer, or excuse me, for every 3 hardware engineers, there's 1 SI engineer. Is that true?
Yes, from the look of it, yes. From talking to customers, that is in big companies true. And sometimes you have one engineer that's both SI and hardware engineers. I know in Keysight, I've heard stories that this one person, he wears many hats. He is the SI engineer. He is a hardware engineer. He's sometimes the layout technician because he just knows so much.
Yeah. Well, good for him. I bet you he's a busy guy, though.
A rock star. He's a rock star.
Rough, man. He's carrying all the weight, but it sounds like like you said, an all-star. So one thing I've been observing in the industry for a while now is, because I've mostly been on the hardware side of things over my career, but because of working at Altium and working on the software side of things, is software engineers have taught me about this famous saying about software eating the world and disrupting industries that you wouldn't think. And so I keep hearing about the impact, like when I was at Altium, trying to get the software to improve that visibility across those stakeholders. And so what's going on in the industry at large? I imagine you see far more than I do. What are companies doing to help bridge that gap?
Great. The way that it's been done is the hardware physical prototype and the software virtual prototype. A lot of times, the traditional approach is, I have this friend Ted. He would tell me back in the days, I'll make a board and I will break it. Based on how it's breaking, he knows how to fix it. Nowadays, you have a virtual prototype, so you don't have to wait for the board to be fabricated. Everything is all in this virtual world that my good friend, Mr. Mike Resser, like to call it a digital sandbox, that you can get your hands dirty and throw in different stress tests that really push the limits of the possibilities outside of the physical realm. You can really turn up the heat in software.
Yeah, and that's definitely something I've seen, where trying to get things in that virtual, because Otherwise, you have to go make a physical bare board,
Right.
assemble it,
Exactly.
and then it's like, oh, it doesn't work. And sometimes you don't even know why it's not working,
Right.
or you do, and then you throw it back, and it's so expensive.
Right.
So I think it's such an interesting trend. So what companies are building? I know that Altium, for one, was trying to build a workflow that helped bridge that gap. What other trends do you see across the industry to help create sort of that virtual prototype?
Well, in my point of view, there are two types of virtual prototype. The ones that is before the layout is made, and ones that
Okay.
it's after the layout is made. What I'll call the pre-layout is where you are doing an exploration of your transmitter, channel, and receiver. That's the pre-layout. And the
Okay.
post-layout, where you have, the schematic is done, then you have the layout technician engineers connect the nets and create a board. That's what we call a post layout. And there are challenges and software tools that can handle both of these cases. Yeah, like Altium is one that handles the post layout.
Are there other tools? Is that mostly existing inside of CAD tools that are doing this? Is that generally where people are trying to bridge this gap? And then I specifically want to put your feet to the fire and ask you about what Keysight's doing, because I know you guys have a software division.
Right. From the industry, on the pre-layout side, you have a lot of channel modeling softwares that can be done, even provided by the standard bodies. And on the post-layout side, you see the Cadence, the Mentor, they all have associated analysis within their tools to help do impedance analysis, control impedance analysis on the layout traces. And Keysight, we, in the spirit of empowering the hardware engineers, will create this layout vendor agnostic tool that's called the EP scan. It will import the ODB++ layout file and IPC 2581 and help you identify the impedance, the skew, return loss, insertion loss of your channels.
Oh, interesting. I like that it's because a lot of the tools that I've seen are just measuring for impedance, but I think that's very interesting because I've learned from people like Lee Ritchie and even some of the material manufacturers trying to solve this problem, that skew is just because of the speeds and that fiber weave effect and all of that is a big deal.
Right.
So I think that's interesting that it's measuring for skew too. Does it measure, are those the two primary things that EP scan's measuring for?
At the moment, the release, it's impedance, skew, insertion loss, return loss. In the future, diagnostics, we're having eye diagrams too. Yeah.
Wow. And so I like that idea. Actually, I didn't have any idea that what Keysight's doing is doing a what do you call it? A platform agnostic way to measure, which I think would be really
And that's
it's like democratization.
Exactly.
Which, I've heard other people. I talked to a couple of the executives from Keysight when I was at DesignCon, and they were talking about that term, the democratization. And I know I've heard Altium talk about that too, is to make it accessible for everybody. So I think that's really interesting.
Yeah, the Altium A365, it's wonderful to use.
Yeah. It was very fun to be there when they were developing that. And I know they're still working hard to do that. But I think that them coming up with that during COVID was really a providential moment, because I got to see from the front lines how that was empowering, engineering teams, global engineering teams that were going down because they didn't have access to VPN or whatever. So that's why I'm really curious to learn about, because I know they're not the only one doing this, right? It's an industry trend, and I love what I'm hearing about EP scan. So what do you think the benefits of EP scan and some of these other tools as we're trying to, as an industry, solve this? I would I imagine time to market, right?
Right.
You save money because you're not building physical prototypes. Are there other things that maybe I'm not thinking of?
Yeah, another big phrase is the key phrase is shifting left, especially for Keysight, is we're moving everything more towards your left hand side, or hence the shift left. And in my mind, shift left is a movement where you're doing as much as you can in the software side, in the digital sandbox.
In the digital sandbox. I
But
love
at the same
that.
time, not ignoring the connection between the software and the hardware, because they are there. And that brings us back to the communications between different parts. Because no man is one island. We are all connected. Design cycle is connected. Part layout, part hardware, part SI. And the trend of the industry, I can see that is, it doesn't matter what product, it doesn't matter what service, it's to make each of ours life better and realizing our real potential in many ways.
Right.
Yeah.
Yeah, that's kind of the I don't know, the vision of starting the ecosystem podcast, because I keep hearing people like you talk about, man, if we do more in a digital domain and we do it, together as a connected ecosystem. The problem is the ecosystem has been disconnected and that throwing over the wall. But most things I'm hearing from people like you, Tim, is can't do it anymore. Speeds are too high.
Yeah.
And I can't do my job without knowing what your job is. So, and one engineer I know came up with this great term that I just absolutely hijacked. A guy named Eli Hughes. Thanks, Eli. He calls himself a full stack hardware engineer. Isn't that a great term?
It is a great term. Okay, so for me, I know there's a full stack software because they know.
Exactly.
And the one thing I find the most interesting is the Stackup of the circuit boards. You have different Stackups, and also full stack could be upon.
I know. See what we did just there, Tim?
All right.
Yeah, I know. So anyways, feel free. I'm sure Eli wouldn't mind you hijacking
trademark
that term too. Yeah, right? And I love that. And I think that's true, is sort of this connected ecosystem or this full stack, right? And it's a trend I'm seeing that I just picked up on. And so I'm trying to do that through conversations like this.
Right.
So, and I think it, especially now that we're all working from home, right? We can get that kind of real-time communication in a virtual environment.
Right.
Which speeds up efficiencies, time to market, all of that. So it's pretty exciting. So, did I just hear you say that you just had a recent release of EP Scan?
The recent release is January 18th, and the next one, update 1, is going to be in April. Okay,
so ongoing roadmap to get it fully built out.
And a shameless plug here, there is a Live from the Lab. Great action in Live from the Lab. We are putting PCB boards inside liquid nitrogen. Do not do that at home. I think you'll find this very interesting. Well, the audience would too, Judy. It's a very fun.
You guys like blowing stuff up and whatever. I'm a geek enough that's like, oh, what are you going to blow up with liquid nitrogen? So make sure you give me that link. When is that going to happen? I will put it in the link because I know our audience will want to see that.
It's March 14th. And I think there's a drawing for, I don't know, a Ferrari worth of hardware equipment, I think. Don't quote me on this. Software licenses, how about that? Trial license for everybody.
Right. So, and Live from the Lab, that's done with our mutual friend, Daniel Bogdanoff, right?
Yes, Mr. Daniel. The fun
Mr.
guy.
Daniel, he is so fun.
Yes,
I love watching his stuff. He entertains as well as doing fun experiments that I think everybody loves.
Exactly.
Well, as we wrap up here, Tim, besides Live from the Lab, and I'll be happy to link to the EP Scan page. Is there any last minute thoughts before I let you go? I know you're a busy guy, or anything else you'd like to share.
I'm just really motivated and encouraged by the trend of the industry. Especially, I saw you at DesignCon, Judy. It's every time you see all these engineers together that bring in their passion,
magic.
and it's magic, and you just see the peace and the love it's gonna create, and the joy all over. And that's what we do. What we do is the peace, love, and joy. Won't you say?
Peace, love, and joy, baby.
That's right.
You know, we're going back to, my childhood now. Peace, love, and joy.
Yeah.
Good times.
Good times.
Well, I agree with you. There's nothing like the magic. And I've seen it over and over and over in my career, and something I'm passionate about is getting that community together.
Right.
Because the amount of collaboration and the problems that get solved and the enjoyment we get to be around our geeky peers is really, really magical.
Yes,
So
yes.
thanks so much. And again, so good to see you again. And thanks for sharing all this. It's really fun to learn from you out there on the front lines with engineering teams.
Thank you, Judy.
For our audience, thanks so much for joining us today. I hope you enjoyed learning about this little read from Tim Wang's Crystal Ball. And it's all about love, peace, and joy. Thanks so much for joining us. We'll see you next time. Make sure you like and subscribe so you can become part of our community. Thanks for joining. We'll see you next week. Until then, remember to always stay connected to the ecosystem.
Peace.